Right. Right, so I'm reading from the syllabus, section 3, introductory calculus, right? Section A, differentiation. Students should be able to, 1, use the concept of the derivative at a point x equals c as the gradient of the tangent to the graph at x equals c. They say use the concept, so you don't have to derive it. You may not even have to explain it, which I took the pains to do so that you can understand what it is and at least have that knowledge when you're using it, right? So that is in the video. Point 2, define the derivative at a point as a limit. That is also in the video as well, right? You all will have your notes from a textbook from a class. It's in my video and it's in the other playlists on YouTube as well. So we don't have to go over that. That there already, that is the foundation, right? This displacement time graph, velocity time graph, we'll get a little deeper into that later. The gradient of a curve, we will be doing some of that tonight, right? Use the different notations, right? No problem. F prime x, dy dx, right? Dx of x to the power of n, etc., etc. Right. So what I want to cover tonight is leading off from the discussion on the curve, the limit and the gradient of the tangent and all of that. I want to do some actual questions, which I would have sent to you all in your WhatsApp. These are Cambridge questions, right? But before we do the Cambridge, I want to actually start off by doing the specimen paper question in the new specimen paper, right? You all wouldn't have it. I will call out the question, right? And then I'll go through it. And then we will do some of the Cambridge questions. All right. Now, of course, at different points in the question, I will stop to give you all a chance to tell me what all you think is the procedure. Tell me what all you think is the answer, right? I don't want all you to be shy. I don't want all you to hold back, right? If it's wrong, we will fix that. That is what we're here for, right? This is not a place to be afraid of being wrong. This is not a place to be afraid of making a mistake. Here is where we come in to fix the mistakes. So if you have something in your head and you want to say it, right? You know, in life, we normally, the general wisdom is that you don't always see the first thing that comes to your head. This is a place where you could do that because I want to get all you in the habit of expressing all yourself. Don't hold back, right? All of this is part of the psychology of this thing, right? Add.Maths is serious business. Don't mind us talking a little bit before we start, but the mind, psychology, very important, even more so than maths, right? I expecting everybody here to get through the maths, right? But as you do the Add.Maths, you might see 1 or 2 areas where you need to double check on the maths. All that is part of it, right? So I just want to start by actually writing the actual derivative, which we all are aware of, but I'm doing it just for the sake of revision because we're starting slow and then we will accelerate, all right? We know that the differential of x to the power of n is nx to the power of n minus 1. That is what they have in the syllabus, right? To that, though, I want to add that the derivative of a constant by x to the n is equal to the same constant. Hold on. Is equal to the constant by the derivative of x to the power of n. So you can either take the constant out and differentiate x to the power of n by itself, or you could differentiate everything, which in effect would be just differentiating x to the n and then multiply by the constant k. So in both cases, the final answer would be k by n x to the power of n minus 1, right? So these are the little details that I want to make sure all you have done because I don't want to take the chance of taking stuff for granted. Everybody know this. We're cool with this. We could differentiate x to the power of 5. We could differentiate x to the power of 3. We could differentiate x to the power of 4. Right? What about if we have to now watch it? Now this is the part I want to pay attention to. Now I trust that everybody okay with this, right? So I'm not going to spend too much time on this, right? General example, the differential of let me say x squared. Simple example is equal to 2x. We know that. And the differential of, let me say 3x squared will be 3 by the differential of x squared, which will be 6x. We could do that, push, quick, right? We're okay with that. So let me switch it up a little bit now and harass a little bit. And this is the part where I want my students, especially my students, make it personal now, right? This is the part where I want my students to be able to think in the exam. Suppose you go in the people exam and you get this. In some way, shape, or form, you get something like 2x to the power of root 3 plus 1. And they ask you to differentiate that. What you gonna do? Right? Suppose you get something like minus 7x to the power of 1 over root 3. Suppose you get something like that. Right? I'm not saying to go in expecting that, you know. But if for some reason you get something crazy like that, you still have to be able to function. Your brain not supposed to freeze if you see that. Right? So the differential of 2x to the power of root 3 plus 1, right? So d dx of that, we're following the same rule, right? We take the constant 2, and we take the whole power of x, and we minus, no, it will be this. So 2 into root 3 plus 1, x to the power of root 3, right? To do that, suppose they say something like, watch this. Suppose they give you, coming back to this just now. Suppose they say, find d dx of minus 3x to the power of, let me see. Yeah, something like this. No, let me use the same, right? Suppose they say find the differential of this, and they say leaving your answer as a surd, right? Leaving your answer as a surd, right? That is the kind of thing I want to talk to you about. We're not going to stop at x squared and x cubed at x to the minus 3. No, we're going a little beyond, so that if something happens and you get something like this, which is quite possible, you could function, right? So just to finish this off, if you get this in an exam, you know that d dx of minus 7x to the power of 1 over root 3 is equal to minus 7 by 1 over root 3, x to the power of 1 over root 3 minus 1. And then at that point, the only issue is to deal with that here, right? I wouldn't do that here now, because that will take time that I don't want to take now. But if any of you, and I'm giving you all this opportunity, no, I can leave this as a challenge if you want to work it on your own. If you want to work it on your own and you want to liaise with me on a one-on-one, I'm giving you that option, right? So I'm not going to spend time working out this, because we had to multiply minus 7 over root 3. We had to rationalize this and express it as a surd. We have 1 over root 3 minus 1. We had to combine this and express it as a surd. See how much things are thrown in there? There's a revision in section 1. Surds, rationalizing surds, the complex conjugate, etc., etc., etc. Right? Nice. So I'll get the opportunity to revise something there. Try it on your own. If you want to just try it and show me the answer, you could do that. If you want me to go through it with you, I'll give you all the option. Right? Nice. So you had to be able to do that in general, as a general differentiation of x to the power of n. In our next session, we'll do the trigonometric differentials, sine ax, cosine ax. All right, the syllabus doesn't treat with tan of ax. I may mention it very quickly, but we're not going to work any questions with tan. All right, at this stage of the game, we don't want to stray too far from what the people actually put in the syllabus. All right, so with that in mind, let us now go into the nice part of this session, which is to do the questions. All right, anybody have any questions before we proceed? No? Okay, I'm taking that unanimous silence as a unanimous no. All right, so let me start with the actual question in the specimen paper, which I will send to all at some point not too long from now, because I had to put it up on the website too, but I will send it to you all as well so you could actually see what your exam going to look like. Excuse, right? Remember, your exam is not going to be an exact resemblance of the past papers, because your exam is the first exam in the new syllabus, the 2018 syllabus. So keep all these things at the back of your mind. You will get the specimen paper probably by weekend. So you have a clear picture of what your exam is going to look like, and then you can let that inform your preparation. So I'm going to read the question. I'm going to read it slowly, which will give you all the opportunity to write it out. It's just one paragraph, but this paragraph have a lot of information in it. I will give you all the opportunity to write it out, right? If anybody come afterwards and they tell me they missed the question, it means it wasn't there when I read it, in which case you just simply have to go back in the video, all right? So, question 4, part B in your specimen paper. Part B reads as follows, for 6 marks. So you're getting a picture now of how the thing could look in your exam, right? A function given by, hold on. Let me rub up this here now. Right? A function given by, I like that question so much, I'm leaving it up for a little while. Right? A function given by y is equal to px squared plus qx plus r. Px squared plus qx plus r has a gradient. The gradient is 6x minus 6 at a stationary value of minus 2. Right? I just putting down the values as I read them. Right, so let me read it. Let me start over again. A function given by y is equal to px squared plus qx plus r has a gradient of 6x minus 6 at a stationary value of minus 2. Using principles of differentiation, find values for the unknown variables p, q, and r, and hence determine the function y. No, I think this have integration in it. Anyway, if it have integration, I'll work it out still, because we've done here already, right? The other Cambridge questions is more straightforward differentiation. So let me see, because this is the kind of question you could get in your exam because it's here, right? So using principles of differentiation, so they give it that clear. So let me start with the differentiation because that is what they tell you to do. Right? So again, one of the foundation principles in this maths is the simple willingness to just follow the people's instructions. You have nothing to gain by trying to prove your brightness or your intelligence by doing something else from what they tell you to do. Right? You just have to follow the instructions. Right. So if function y is equal to px squared plus qx plus r, then the first thing you want to do is differentiate y. Whew. Come on, don't move now, man. The first thing you want to do is differentiate y. So if y is equal to that, it means then that dy dx, right? See the kind of question? It's not as straightforward as the normal ones, right? dy dx is equal to, we differentiating 2px plus q, right? And they already told us that the gradient is 6x minus 6 at x equal minus 2. Now, they didn't say x was equal to minus 2, you know. They said at a stationary value of x equal, at a stationary value of minus 2. So you are expected to know what that means when they say a stationary value of minus 2, right? The stationary value stationary value means x equals minus 2. Let me just leave it at that, right? And if the stationary point occurs at x equals minus 2, that has implications again. But we come to that now. So if 2px is equal to 6x minus 6, well, we can see then, in fact, I kind of skipped some lines there. If dy dx is equal to this, then the next line is to say, let's stick with the black. Sometimes I get too excited with just changing color story. Therefore, 2px plus q is equal to 6x minus 6. So we have a special technique here which we refer to as equating coefficients, which we sometimes use in solving questions on the remainder theorem. But in 9 cases out of 10, you could get away with doing the solution without doing that. But it's still a technique to be aware of because you need it here. So if this is equal to that, then it is clear that you could say, therefore, 2p is equal to 6, in which case p is equal to 3, and you can say that q is equal to minus 6, right? So you get the two values here already. So p is equal to 3, and q is equal to minus 6. But we need to find r. Well, let me see what's happening here, right? Now they say that the stationary value is the stationary value is x equal to minus 2. So in other words, it means then that dy dx is equal to 0 at x equal minus 2. How will that help us here? Okay, hold on. Any of you have any ideas? Throw it out now. Let me see what's happening here, boy. A stationary value of minus 2. A stationary value of minus 2. Oh, no. My mistake. My mistake. Sorry. Stationary value. It means the stationary value, the value of y is minus 2, not x. So you see, big mistake here. So let me get rid of that one time. Let me be clear on that. Right? You see why it's important to do these things, right? So even when I make a mistake, me have no problem with that, right? The stationary value is minus 2, right? It doesn't say at what value of x that value occurs, right? The stationary value is minus 2. We could find the value of x here, but we come into that just now. It means that y is equal to minus 2, where you have a stationary value. So in other words, now, listen to this carefully. Because your dy dx is linear, there will only be one value of x for the stationary point. So in other words, you start off with a quadratic curve. Your gradient function is a straight line. And when you're trying to locate the turning points, you'll get one value of x here, which we could use because they already gave us this. So this is the gradient when the stationary value is -2, which is to say then that this is what we have to use to find the value of x for which the stationary value is -2. What does it mean when we say the stationary value is -2? I'm rubbing off this part in black here, right? I'll have the recording, or you'll go and check it out. Let me just give a quick visual depiction of what that means, right? That's what's the values? P is equal to 3 and Q is equal to -6. We don't know what R is yet. So that curve is what? Y is equal to 3x squared minus 6x plus R, right? So that is a minimum curve. So that curve will look something like this. That curve will look something like this. That is your -2 there. So this is what they mean when they say that the stationary value is -2, right? See how much things you run through here quickly, and some of this could come in your math section too as well, right? Now, what we want to find is this value of x here, the value of x for which the stationary value is -2, right? That, of course, in your maths would correspond to your, what do you call this line again? Somebody help me out here now. What do you call this line again? The equation of the geez and ages. I forget. It will come to me, right? So this line, you want to find the equation of this line. I forget the name of it right now, but we'll get back to that. Now, they tell us that the gradient function is 6x minus 6, right, at the stationary value of -2. And we know that by definition, when you have a turning point or a stationary point, the gradient is equal to 0. We know that. You see how much things, simple question like this, about 3, 4, 5, 6 different things coming together at one point. Which means then that we're now in a position to find the value of x, this value of x here. So if 6x minus 6 is 0, it means that 6x is equal to 6, which means that x is equal to 1, right? So this is the value, x is equal to 1. It means then that the coordinates of the stationary point would be 1 minus 2, which they could have asked for as well. They could have made a direct request for this. They could have said, blah, 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 find the coordinates of the stationary point, which means that you have to find the x value here, having already received the y value. So now that we have the value of x, we could then plug it in up here to find the r. So we were able to find p and q by the straightforward differentiation. We had to get into a little extra semantics now to find the r. And that is why this is worth 6 marks. So I hope all is seeing this Add.Maths is not to be played with, right? This is not something to mess around with. You have to take it seriously. You see how much things we had to deal with in one little question, right? So, well, I get a nice graph there, right? So I'm rubbing that off now because we're on the small board. And being on the small board means that we don't have as much space as when we're on the big board. So we had to find r still. So at the stationary point, 1 minus 2, we will now have that, and I'm going to superimpose here now, right? We'll now have that -2, p is equal to 3. 3, x is equal to 1 by 1 squared plus q is equal to -6, minus 6 in brackets, X is equal to 1 plus R. So now we're in a position to find R because they have everything else from the original equation, right? So we go in. So minus 2 is equal to 3 by 1 minus 6 plus R. So minus 2 is equal to 3 minus 6 plus R. So minus 2 is equal to minus 3 plus R. So minus 2, so 3 minus 2 is equal to R. Therefore, R is equal to 1. Nice. So P is equal to 3, Q is equal to minus 6, and R is equal to 1, right? So in other words, the equation of the curve is that y is equal to 3x squared minus 6x plus 1. So they could have also worded the question by saying, find the equation of the curve. So instead of asking you to find P, Q, and R, they could have just said, determine the equation of the curve. And the only way to determine the equation of the curve is to find the values for P, Q, and R. So again, you get a sense of different ways in which you can ask the same question. All right. Now, if I move a little fast here, fine, no problem. That's why I have the recording. So you can go back and listen and pause and all of that, right? Once we finish here, that is up to all you. I have no control over that. The most I could do at that point is talk and cajole and encourage and exhort, right? And hope that if I have a problem, all you know how to find me. All right, nice. Anybody have any questions on that particular question that we just did there? Anything that you want me to run through quickly? Anything that, no? Going once, going twice. Somebody say something, let me just make sure all here now. All here?
Yeah.
Okay, right. So you're okay with all of that there, right? No problems there at all. Nice. So let me choose a couple from the Cambridge questions. All right. We'll do about 2, then we'll take a little break, and then we'll come back again. Right? I know how it is. 34 minutes. We ain't do so bad so far. All right. All right. So Cambridge question. All I have it on all your phone. So no need to read the whole question. All right. We got to use the technology and use it properly. Come download now. Okay. Oh, okay. Hold on. I had it in the wrong window there. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So the first question I'm going to do is a question with a graph. So in other words, I throw in a different kind of question. So if you scroll along in the questions, you will see question 12. That's kind of like in the middle of the question there. I will draw the graph on the board, and then we will discuss the question. Right? Nice. Again, if anybody have any issues, feel free to interrupt, right? That's what we're here for. All right, so the graph looking something like this. What's your graph now? The graph is nice, fancy graph, man. So they give you a whole curve there, and they give you the equation like this, right? So this is part B. This is O. Right, it's going through O there. Right? And this is A. Right? This is the x-axis, and this is the y-axis. This is the point 1, 3. Right. Now, part B, they ask for the area of the shaded region, which is integration. So we're not going to do that part tonight. Right? We could always come back at a later date and do it. If anybody curious enough and they want to do it and send it, you're always welcome to do that. Nice. Y is equal to 4x minus x squared. Right. Excuse. So the first part is the part we're interested in here. The diagram shows the curve y is equal to 4x minus x squared, which crosses the x-axis at the origin. So you have that information. And at the point A, will be point A here. Right? The tangent to the curve at the point 1, 3 crosses the x-axis at the point B. Find the coordinates of A and B. Beautiful question. Beautiful question. So I'm going to work it out. Nice. Take all the time and watch what I'm going to do. Yeah, you have the recording, but try and do as much as you could now so that you have less to worry about afterwards. So we want to find the coordinates of B and the coordinates of E. That's what we're looking for in this question. Right? Right, so let me ask a simple question. Which one are we going to find first? Which is the easiest one to find first? Which is the easiest one to find first? Somebody, quick. Somebody say something now. Okay, look, Mark Rich. Hold on. Right, so we have the full squad aboard. Yeah, somebody saying something. I hear somebody breathe just now. The mic, the mute was off, and I hear somebody breathing. Somebody say something now. If you're wrong, you're wrong. It's a dialogue we're trying to have here, you know. A? Okay. Right, so the answer is A. Tell me why A is the easiest one to find. I just probing at all here now. Sorry, not easiest one. Why A is the first point we want to find?
Lie on the curve.
Okay, no problem. That's a good response, right? In fact, that's an excellent response because we already have the equation of the curve. All right. So A, we could find that straightforward. We just put y is equal to 0, boom, and we get these two answers one time. We do not just know. Now, how we find in B? That is what I want to find out. What we have to do to find the coordinates of B? They give you the diagram, you know. They give you the whole diagram, which is not something they usually do. So every now and then you get a diagram in a question, but usually they will tell you what the scene is. How we find any coordinates of B? Hello. Wake up, shake up.
You have to find the equation of the tangent.
All right. This is what we want. So in other words, I'm not just going to come here and do the question, right? I kind of probing at you all because I'm taking you all through the thought process. This is what you have to go through under exam conditions, all right? So as often as you get the chance with me to actually say the whole procedure out loud, it gives you the chance to reinforce the steps in your own head, to reinforce the fact that you're thinking about this thing, right? You have what is clearly a tangent here. There is no doubt that this line is a tangent. Did they use the word tangent at all? Right, they did say that tangent, so you don't have to worry about that. And this is the 0.13. So yes, we have to find the equation of the tangent. And after we do that, we do whatever we need to do to find B. Right, so I'll take that for now. Now I could proceed with the working. So let me find A. We find A by equating y to 0. So y is equal to 0, which is to say then that 4x minus x squared is equal to 0. This is straight out of your maths question 2. Factorization, solving a quadratic equation. All right. So anybody who need to revise that, all you know what to do, it's on the maths website. Excuse. So you factorize 4x into 4 minus x is equal to 0. Just one note here. Do not, in this situation, do not divide the equation by x. So let me show you what some people do. They will say 4x minus x squared is equal to 0. And they will divide by x and say 4 minus x is equal to 0. You could do that. But when you do that, you'll be actually throwing away a whole solution. All right, because as you could see from the graph, there are 2 roots of the equation. See, you're swinging back to section A now with the vocabulary. Once you have a quadratic equation being equal to 0, you know you have 2 roots. Whether it's 2 real roots or 2 imaginary roots or 1 real and 1 imaginary, whatever. Right? So as a general guide, and this will help you in your maths as well. You have a quadratic equation equal to 0. You know that instead of doing that, you factorize x into 4 minus x equals 0, and then you take the 2 solutions. Right? Now, because you all are Add.Maths, I just want to write the answer straight here. So we know at this point, the answer will just be x equals 0 and x equals 4. All right? We know how we get on. Anybody who have any doubt at all, it's in the maths website, in the quadratic video. Nice? So we know that A is equal to 4. Therefore, A is equal to 4. Now, did they ask for the coordinates of A or the value of A? The coordinates of A and B. Very important. These are the little things that they had to take into account. If they ask for the coordinates of A, you're not going to put A is equal to 4. 4 is not a coordinate. 4 could be an x coordinate or it could be a y coordinate. When they ask for the coordinates, plural, it means that they want both x and y, in which case your A is equal to 4, 0. Right? That is the answer. You could put A equal to 4, 0. You can write it like that if you want. But this is what they're looking for when they correct it. All right? So A is equal to 4, 0. We know that the origin is 0, 0. Now we're going to find B. Let me ask you a trick question here. What is the y coordinate of B? Easy trick question. Or you could have won plenty of money, if this was on that quiz. What's the y coordinate of B?
0.
Ta-da. 0, yeah, right? Again, I throw in these things at all randomly just to wake up some circuits in your brain, right? These are not things to take for granted. You look at that, you know that the y coordinate is 0. And you chuck that in the back of your mind somewhere and you get about your working. All right, so let us proceed now to find, now we're differentiating nothing here yet. To find A, we ain't differentiate yet. Now we have to differentiate because we have to find the equation of the tangent. So we done find A already, so let me find B now. So the equation of the tangent, we have the curve here, so we know then that you differentiate dy dx is equal to differentiation, boop, 4 minus 2x, right? Right. So At the point 1, 3, the gradient of the curve, we had to use this here. So in other words, the gradient of this line, yeah, M, if we were dealing with coordinate geometry in your maths, yeah, M is given by the value of this function at x equal 1, right? So if you're writing this out, you could say at 1, 3, dy dx, or sorry, let me use some straightforward language. At 1, 3, the gradient is equal to 4 minus 2 by 1, which is equal to 4 minus 2, which is equal to 2. So we know the gradient is 2. So we have the gradient, and we have a point through which the line passes. So again, back to your coordinate geometry in your maths. We now in a position to find the equation of this particular straight line, which is the tangent. All right. So ding, 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 ding. Right. Everything here. So rubbing it off again. You can check the recording when we're done. So we know M is equal to 2 because we were able to use the gradient function and the value of x. M is equal to 2. So equation of the tangent. Equation of the tangent is equal to y, normal thing, y minus y1 over x minus x1 is equal to 2. Well, 2 over 1. You cross multiply, you get y minus 3 is equal to 2 into x minus 1. So y is equal to, no, I can't do all of that. It's moving a little too fast. Right, so we're coming up on the top here now. All right, so y minus 3 is equal to 2x minus 2. So y is equal to 2x minus 2 plus 3. So y is equal to 2x plus 1. All right, so if y is equal to 2x plus 1, what's the coordinates at this point here? Haha, trick question again. What's the coordinate at that point?
1.
What's the coordinates? X and y.
0, 1.
0, 1. Right. So let us put a hypothetical C here, which it did not ask for, but which they could have asked for as well. Right. So in a question like this, they could have also asked for the coordinates at this point. And we call it C, 0, 1. So again, as we work out the question, we take a little detour to deal with something. So now it's like when you're going on one of them excursions. Now, I don't think anybody here old enough to be going on excursions, but all you know what an excursion is, right? You go on the beach and you stop on a bar along the way. You stop at a bar, or you stop by a parlor or by a shop or by a grocery to get a whole set of things. So we'll do that from time to time. We work in a question and we make a detour here, we stop. And all that is part of the learning process to reinforce what we already know. So now that we have the equation, shoops, we now in a position to find the coordinates of the y-intercept here. This here is what we refer to as the x-intercept. So in the same way that you have a y-intercept, you also have the x-intercept. For whatever reason, the term x-intercept is not as common in the vocabulary when we're talking about straight lines, but it's the same concept. Y-intercept, x-intercept, right? Throw some vocabulary at all of them. So how we finding this? We finding this the same way that, the same thing that we did here, we're doing it for the straight line, which is we equate y to 0 because the line actually cuts the x-axis, and we know that the equation of the x-axis is y is equal to 0. We also know that the y coordinate is 0 here by virtue of the point being on the x-axis. So if y is equal to 0, we could say then that to find b, so you could say now to find to find b. Equate y to 0. So 0 is equal to 2x plus 1, right? So minus 1 is equal to 2x. So minus 1 over 2 is equal to x. Therefore, the coordinate of b is what? Minus a half, comma, 0. All right? So again, you get a sense of the kind of question that you could get. Notice we had to pull in coordinate geometry here. All right, and this is something that I tell Add.Maths students all the time. Your maths is going to be taken for granted. If you come in here to talk about tangent and differentiation and dy dx, there's no way that you could be coming here to tell me you don't know how to find the equation of a straight line. Or that you come in to tell me you don't know what to do when you have the gradient and a point if they ask you to find the equation of a straight line. Right? So again, this Add.Maths is serious business. If you know your coordinate geometry shaky, then tell yourself you're gonna have problems when you come to do this Add.Maths. Equation of a circle, intersection of a circle with a straight line. That on the course too. Right? So we had to do some questions related to that as we go a little further. Right? Etc. 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 So sharpen it up, fellas. Sharpen it up, ladies. There we go. Right, one more question and then we'll take a little break, right? So take a deep breath. Let me see if I could find a short question. Let me give you our next graph now. Let me make the thing nice, right? So this is the graph segment. And then we go switch to something else afterwards. So if you look at question 10, of course, it's not in any particular order, right? I just pull these from the Cambridge questions I have. Again, the second part we're not going to do because that is integration. Now, that could also happen in your CSEC. You can get integration and differentiation in one shot. So you might get a graph where you have to integrate in one part. Sorry, where you have to differentiate in one part and then you integrate in the next part. What kind of thing? Serious business all there. Wake up, shake up, right? So again, I will reproduce as faithfully as possible the diagram as I have it here in the question. Right? Let me see now. Come. Come, Duster, better than that. Right. I had to be so careful as I hold in this phone here. Yeah, I'm starting to get too excited and then boop. So let me take my time. Serious business. Right, so again, similar type of question, slightly different diagram. So you get one type of question as one segment of the discussion tonight. Right, I ain't hear any ladies at all. Right, so this question we will let the ladies run through it, right? The fellas representing very well so far. So we're looking out for the ladies in this question. So we have the graph. Nice graph again. Same thing, pass to the origin. Right? Look how nice the graph looking. Beautiful graph, man. Right? X and Y. Right? And the equation of the curve is y is equal to x cubed minus 8x squared plus 16x. Nice, straightforward curve, eh? Look how nice all I get in it. Right, the diagram shows part of the curve equation O. Again, they give you a shaded portion here, which we're not going to concern ourselves with tonight, but maybe at a later date, we could do that part of the question as part of our integration practice, right? Show that the curve has a minimum point at 4, 0 and find the coordinates of the maximum point. Nice. So in this case, they give you the coordinates of the minimum point, which the only point they could possibly be referring to is this point here. right? The teller is 40. Okay, fine. So the teller, the minimum point is 40. The question now is that we have to show. I'll have a laugh. I will tell you why I laugh just now. And then they want the coordinates of the maximum point, which clearly is that point there. Now, let me take 2 minutes to discuss something here. Very often when they ask you to show something, a lot of students take that to mean I had to do nothing because they give us the answer already, right? So a lot of students take the liberty of ratcheting the question. So in other words, they ain't really sure what they're doing. But because they already have the answer, they do some kind of back channel, some kind of simultaneous, and boom, you get the answer. No, that's not how we just do it at all. When they tell you to show something, your starting point, you have to behave as if you didn't know the answer. Right? Or again, all of this is part of me giving you some exam hints and strategy. Anytime they ask you to show something, whether it happens in Add.Maths or it happens in maths, right? Those of you who do in physics, you might get some of that in physics too. You behave from the outset as if you didn't know what the answer was. Right? In other words, you're kind of like you almost play stupid then, so to speak. It's something that we do sometimes when we relate into other humans. We know something and you play and know it to see how the thing go. Right? We're doing that in a mathematical context here. You know what the answer is, but you're operating as if you didn't know what the answer is, and you're going through the same steps, the identical steps that you would have to go through if they had asked, find the coordinates of the minimum point. They could have asked you that too, without telling you the answer is 40. So when they tell you what the answer is, it's not that they're feeling to be extra nice. It's not even that they're doing you a favor. It is simply they show you what the endpoint is, and they want to see how they get to the endpoint. They want to see you working. They want to see your steps. They want to see your use of the knowledge that you have to get from the beginning to the end. Right? So you operate as if you don't know what the end is, and you start and then proceed. So we know that if we're talking about minimum point and thing, we had to differentiate, all right? So the first thing you do is you divide the x. Divide the x is equal to 3x squared minus 16x plus 16. Nice? And at the turning points, divide the x is equal to 0. Turning point 1, turning point 2. So you say at turning points, dy dx equals 0. You see how nice you write it out? See how nice we explicate our, well, I shouldn't say that. Explicate it doesn't mean plain fool. Explain, right? I don't want to say explicate because it sounds too much like extricate, which is to pull yourself out of a difficult situation. So you see how again some vocabulary here too. Take that as notes and move on, right? At the turning points, dy dx is equal to 0. So, all right, let me make it 0 now. Therefore, 3x squared minus 16x plus 16 is equal to 0. Right? Right, so we had to factorize. Jeez, I need this. This is the problem when I use this small board. All right, so all you understand what happened here, right? Nice, so this line is important. This line here, very important. You have to communicate. How much marks this question has worth? Hold on. This part is worth 4 marks, right? This is definitely 1 mark, for sure. This here is either 1 mark or half a mark, depending on what the marking scheme is. So in other words, you differentiate 1 mark. This might be half a mark, maybe 1 mark. That is 1.5 out of 4. You have 2.5 marks still to get, which would comprise the actual factorization and solution of the equation. But this here must. All right. So even if you could differentiate, you still have to talk to them. You have to talk to them. You have to talk to them. Right? Don't just write numbers and give them. You have to talk to them too. Right? Talk to your examiners, talk to the people who mark in your paper. So the derivative is equal to 0. So in other words, let me change the color to mark the fact that we skip a couple lines there. Therefore, 3x squared minus 16x plus 16 is equal to 0. Woohoo! Factorization. Question 2. Maths. Algebra. Right? So let me see now. 16 is Add.Maths, right? So let me try elemental here now. 3 by 16 is 48. So we want 2 factors of 48 that will give us minus 16. We see 12 for the 48, minus 12 by minus 4, right? Minus 12 minus 4 is minus 16. Again, is Add.Maths students. So I treat it all in a particular way. I'm not treating all with kids' gloves. We deal with that with the math students. Or they're doing Add.Maths. All right. So again, I just run through that mentally because it's Add.Maths. So we could do that. Right? So you factorize, you'll get 3x squared minus 12x minus 4x plus 16 is equal to 0. All right. Which is to say then that when you factorize, you get 3x into x minus 4 minus 4 into x minus 4, which is to say then that x minus 4 into 3x minus 4 is equal to 0. Right? Now, look at right there, x minus 4. That's the first solution that they give there. All right. So at this point, you have the x minus 4 here, so you know you're doing something correct. You know you're doing something right. Right? So all of that, again, is part of the psychology of doing these questions under exam conditions. You do anything, you say, all right, x minus 4. So you know you have one solution in the bag already. Now you have to fix the next one. So it means then that your x is equal to 4, which you already have here. And x is equal to what? 4 over 3. I even going through the 2 lines there. All is Add.Maths students, all know what that means. All right, nice. So it means then that the x coordinate of this point is 4 over 3. All right, which means that we could now substitute that in here to find the y coordinate. Watch. Remember, I tell you that multiple times. In Add.Maths, the values are not always going to be nice and cute like you have in maths. So for starters, you have an x coordinate of 4 over 3. You had to cube that up here. You had to square it up here. And then you had to minus that. Well, let's see what happens. Right? So I just want to use this opportunity to remind you Add.Maths is not maths. Right? Your ability to work with fractions is taken for granted in a question like this. That throwing you back to question 1 in your CSEC maths. You combine 2 fractions, you add 2 fractions, you minus 2 fractions, blah, 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 blah. Right? Nice. So let me rub off the button there. The graph looking too nice. You don't want to tamper with the graph. Right? So we have the x coordinate as 4 over 3, so we just need to find the y coordinate. So again, they ask us to find the coordinates of the other turning points. So if we have the x coordinate, it means we have to find the y coordinate. And that will give us the coordinates, plural. So y. So at x equal 4 over 3, y is equal to, I need all this space I could get here. 4 over 3 cubed minus 8 by 4/3 squared plus 16 by 4/3. Well, look trouble. All right, so 4/3 squared is 64 over 27. Watch. You see what we had to deal with here? Right? Minus 8 into 16 over 9 plus 16 by 4/3 is 64/3 again. We're doing add maths, so I don't have to explain that all. Right? Nice. So 64 over 27 equal minus 16 by 8, 16 by 4 is 64 by 2 is 128. 128 over 9 plus 64 over 3. What we do here, we make everything a common in. No. Listen. You all are my students, right? All they do is add maths. So when all they come here, I don't want to see none of they doing that. All they pass that stage, man. And I'm saying that with the greatest of respect to mathematics students. If you're doing add maths, then when they reach here, what are you supposed to be able to do? 64 over 27 minus 20, 128 by 3 is how much? 8 is 24, 12 is 36. Somebody help me out here now. 384, yes, 28 by 3 is 84. 384 over 27 plus 64 by 3 is 192. No, it's 3 by 9 multiplying 64 by 9. Jeez and ages. 64 by 9 is how much?
576.
576? Yes, 576. 24. 576, yeah, 9, right. Okay, I've taken that. 526 over 27. Right? Bim, bam, bam. Nice and elegant. Let me do the thing properly now. This is a denominator and LCM. Now we pass that stage. That is for people who do maths. Right? I'm not trying to be elitist or classist or anything like that. Right? But if you're operating at a level, you're operating at a level. You understand what I'm saying? Right. And then you just do all the arithmetic on the top. So somebody do that quick and tell me what that is equal to. Something over 27. Right? Talk to me. I still hear any ladies, but all right. Huh? Hey, look at lady jumping. Talk to me, teacher.
Yeah, 256.
How much?
256.
256 over 27. You see how nice it boils along? Right. So the coordinates of your turning point would be 4 over 3, comma 256 over 27. Woohoo! Look how nice that point looking at, man. Just nice and cute. Now, I know there was a one like this in one of the past papers we did. It was one of those questions where you had something with a straight line and a curve, and you had some 35 or 100 and something. Yeah, there's Add.Maths. You see, we see all of this? That is Add.Maths. So if you didn't know you was doing Add.Maths before, you're sure now. Right, so let me take a little break, right? All you walk around, do whatever all you do, take out 10 minutes, and then we can do about 3 more questions again and call that George, right? So we're doing a stifle session here, but the idea is that for those who have it already, it's just a reinforcement. For those who don't have it, at least you know that you have it, and now you could actually take a decision to do something about it. Right, so let's take a 10 minutes and we're rolling again. What's the time now? It is now 10 past 9, so 20 past 9, right? We roll in and then we run straight through and call that George. Pause this recording a little bit. Right, so we're resuming the recording now, right? So as I was saying just now, the 16 to 19 in the past papers, you had to actually write on the sheet. So what I would strongly advise you all to do is, again, there are more printed to do, right? Sorry to put all it through this, but I want to do everything that I could to take care of some of the little details where this Add.Maths is concerned. right? So in this next set of past papers, what you will essentially be doing is actually printing out the past paper and writing on the past paper. So you have the past paper, you're writing on it, and then of course you scan it. So I see we getting better at the scanning. So let us all make this second phase count, right? Let me make it count. Let us build on what we would have done in the first phase. I would have at some point to schedule a couple of sessions to go through some of the things that I would have seen in the corrections, right? But I have the papers here, so and that's the advantage of me having the paper. I could actually go back and check what all they do, and we could deal with certain things. I could message some of y'all individually. But let me keep the rhythm going and let me keep it strong, right? If we finish this Add.Maths thing early, in terms of the CSEC past papers, we could do just what we're doing here tonight. Double up in some Cambridge questions. We just revising and we just go in. All right, so what? We're in the middle of April now. If we finish the Add.Maths in the middle of May, let me say the 3rd week in May, we then have the whole of June to do the Add.Maths. And I'm talking about, at that point, we're not scrambling to do past papers. Everybody else could be doing that, right? At that point, we finish with all the CSEC past papers. At that point, now we're going back to see any little issues that we would have had in the past papers that we did for CSEC. And at that point, we will be doubling up in some of the Cambridge questions as we do in here tonight. So I hope all you understand what I'm trying to do, right? I don't want all this scrambling in June where this Add.Maths is concerned. If you had a scrambling or some of the other subjects, then do that, right? There will be a certain amount of unavoidable scramble. Hey, I'm having a session here, boy. Yeah. There will be a certain amount of unavoidable scramble, right? Because of the COVID situation. But we're trying to take Add.Maths out of that equation. So they work at manner, cooperate with manner, right? Let me do the thing properly. Right, so let me do about 2 more questions and call that George. If we could slip in a 3rd one, we will see if we could slip in a 3rd one. So it's 23 past 9, so let me finish by 10. All right. So I can send all in all the bed early. I know all the up whole night studying and things. So they'll still have time to do all the other subjects. All right. All right. So private. Opening up the phone again. Shock, not private, sorry. Form 5. I saw a custom when the private students. Geez and ages. All right, so let me choose a random question. Now we leave out 8 because that have product that have quotient rule in it, right? 2x over x plus 9, we haven't deal with that yet. Okay, look a nice question here, boy. Let me see the point, the line x, find the possible values is tangent to the curve. No. We're doing that level of differentiation here, so I can't give all the question 3. See, I just pick the questions fast now. I don't always see everything in it, but. All right, so let me do question 4. Question 4 is a straightforward revision. Wait, hold on. Yeah, a straightforward revision of the whole concept of finding the turning points and finding the nature of the turning points. Straightforward, straightforward. So we started with some complicated questions and we can dip back now and deal with some straightforward questions, all right? So it's not every time that there will be a catch in the question. Now, you might get a question with a catch in it in the final exam. But the first step to being able to do the complicated questions is being able to do the simple questions properly. being able to do these simple questions well. Don't take simplicity for granted, because simplicity is the platform that will allow you to jump off into the complex questions. All right. So in this question, they give us the curve. They say find the coordinates and the nature of the stationary points of the curve. I mean, you couldn't get it more straightforward than that. Y is equal to x cubed plus 3x squared minus 45x plus 60, right? And all I'm saying, why didn't start up for this question? Well, yeah, I could have done that too, but make the session nice now, right? You start off with the tricky question and then the back into the simple one. So we get a total picture. So we want to find the coordinates and the nature of the turning points. In other words, know the vocabulary well. We have to locate the turning points. And after you locate the turning points, you have to, what's the other one to use? Let me say, classify the turning points. Yes, I had about 4 words there. I had to choose the right one. Right? So you want to locate the turning points and you want to classify the turning points. Right? Now, I don't think you all have to do points of inflection in all the syllabus. Let me double check that. Hold on. Whew. When you have all these documents out here, boy. Hold on. I will tell you. Right, so let me just give a quick review from the syllabus. They say use the concept of the stationary points, right? Right, they stated here. Points of inflection not included. So you don't have to worry about points of inflection, right? So if we see any points of inflection here, we will brush it over quickly. But I will mention it just for the sake of general knowledge, but I wouldn't dabble up in it too much, all right? So the first thing we want to do to locate the turning points is to differentiate. So your dy dx is equal to 3x squared plus 6x minus 45, right? And because at some point we'll be called upon to classify the turning points, it means then that we have to bring in the second derivative, right? So this is the first time for the night that we're dealing with the second derivative. So the second derivative is d2y x squared, or y double dash, right, is equal to 6x plus 6. So again, just to make a quick note, right? Some people prefer to use y dash and y double dash. No real difference there, right? I kind of old school where this is concerned. I like my dy dx and d2y dx squared. Old school, classical stuff. Everything, different things now, right? But that's an honest issue. However you prefer to write it, you write it like that. So when we want to locate the turning points, listen carefully to what I'm saying. Hopefully, the way in which I'm breaking it down will help you to remember it. When we want to locate the turning points, we use dy dx, the first derivative. Let me use some. So in other words, you're using dy dx to locate the turning points, and you're using d2y dx squared to classify the turning points, right? So when you want to locate the turning points, you use dy dx. When you want to classify the turning points, you use the second derivative, right? Hopefully something in there will help you to remember what we're talking about. Right, so we need the space now. Right, I took it in the corner here. So you want to locate, and you want to classify, right? I was trying to find a simpler word than classify now, but we go use that for now. That was the simplest of the options that I had. All right, so dy dx, we know that in locating the turning points, your dy dx is equal to 0, all right? So you see for turning points, for location of, now writing all of this in the past paper might be kind of tricky, which is why I want all it to print the past paper and write it out on the paper itself. So you start to get accustomed to squeezing stuff in the space. So you're not going in the exam and you're fighting up to write. No. You had to get accustomed to that, right? Emmanuel, I know you don't have that problem because you'll write a whole exam on one sheet if you could, right? Brandon, on the other hand, is somebody who like to take his time and write out everything. So everybody had to figure out how they're doing this thing in the space that they give us, all right? For the location of the turning points, dy dx equals 0, right? dy dx equals 0. So even if you don't put this, you see this here? Don't play with that at all, because this is what they're looking for. They want to see that you recognize that equating dy dx equals 0, equating dy dx is 0 is what will give you the location of the turning point. So dy dx equals 0, which is to say then that 3x squared plus 6x minus 45 is equal to 0. Right, so trick question. Let me see. Let me throw this one for the ladies. I only hear one lady for the night so far. 3x squared plus 6x minus 45 is equal to 0. What's the first thing we do here? In fact, what you notice about the equation? Ladies, fellas, let me give the girls and them a chance. Ladies, talk to me. Ladies, I want to talk, boy. Sure. Rastafari, yeah? We have there. Khadija, say something now. Sarah, what you seeing there? It's only two all now, not to share a gun. Hello, testing 1, 2. Jeez, natures. Ladies, I want to talk at all, but all right, fellas, let me do what we had to do. Fellas, talk to me. What all you notice about the equation?
Is that quadratic?
Yes, it's a quadratic. You notice anything else about it? So if you had to factorize this, what you'll do?
I would multiply A and C, and then
All right.
AC, wherever I multiply, and then wherever I add it to get B.
So you're saying that you'll multiply 3 by 45, right? That's what you'll do?
Yeah.
All right. Have
So
anybody seen anything there?
so you could divide the entire equation by 3.
Yeah. Observation, right? So again, all this is what you have to deal with in an exam. 3x squared plus 6x minus 45. And the only reason you could do that is because the entire left side is equal to 0. Right? So with the left side being equal to 0, it gives you a lot of flexibility in terms of finding a common factor and dividing. So if you realize that the whole equation is divisible by 3, let's divide by 3 now. Make your multiplication easier. So before you go through the AC, you say x squared plus 2x minus 15 is equal to 0. And at that point, the equation is so simple that you don't even have to go through AC. You know immediately that this is x plus 5 into x minus 3 is equal to 0, in which case x is equal to minus 5 and x is equal to plus 3. Of course, if this was x squared minus 2x, the signs will be the reverse. It will be x minus 5 into x plus 3. All right. So anytime you have the opportunity to simplify your working in these cases, do it. In a lot of cases, very often in this Add.Maths and in maths as well. And it usually happens when you have to deal with a quadratic in another context. So in question 2 in the maths, they will just say, all right, solve a quadratic and they solve the quadratic. So you're here doing a differentiation question and you have a quadratic to solve. But in a lot of cases, and this case is one, you will find that the entire quadratic is divisible by a particular number. Excuse me. In the Add.Maths, look out for the case where the common factor is negative. You might realize that the whole equation could divide by -2. All right, divide by -2. Or you can multiply by -1 first and then divide by 2, which is the same thing. So all of these little workarounds you have to be able to do, right? Make your life a lot easier than multiplying 3 by -45, which would be what? -135. And then you got to look for factors of -135 in an Add.Maths exam. 2 hours and 40 minutes, right? So look out for stuff like that, right? So having gone through this little thing here tonight, it could put you on the alert. So when you watch the quadratic, take a quick scan at everything there. If you notice that anything is divisible, then you divide and then you factorize, right? So one little tip in there, right? So we have x equal -5 and x equal 3. Did they ask for the coordinates? They asked for the coordinates, right? Right, find the coordinates. So if they ask for the coordinates, it means that we had to give them x and y. So when x is equal to -5, your y would be what? Right? So you say at x equal -5, y is equal to what? -5 cubed plus 3 by -5 squared. Now here's where it's to get real sticky, right? -45 by -5 plus 60. So -5 cubed is -125. 3 by -5 squared is plus 3 by 25. 45 by 5 is plus 225, right? Minus by minus plus 60. Right, somebody help me out with the calculator here now, right? -125 plus 75. 225 plus 60 is plus 285, all right? That is -50 plus 285, which is equal to 235. So one point is -5 to 35. Geez and ages, what kind of point you talking about, right? And the next point is using x equal 3, right? So this is a smaller number and it's positive, so it should be a little more straightforward now. So x equal -3. So at x equal 3, your y is equal to 3 cubed plus 3 by 3 squared minus 45 by 3 plus 60. All right, which is equal to 3 squared is what? 3 squared is 27 plus, notice how I'm making everything in brackets, right? 3 by 9 minus 45 by 3 is 135 plus 60. So 27 plus 27 minus 135 plus 60 is minus 75. So you get 54 minus 75, which is minus 21. All right, so the next point would be 3, minus 21. So you have the two stationary points. Now they ask for the nature of the turning point. So in other words, we now need to determine whether it's a maximum point or a minimum point, right? In the case of the CSEC, you wouldn't be dealing with points of inflection. So let me just work it out and see what we get. Right, so to classify the turning points, we turn to the second derivative, d2y dx squared, right? Which is to say that in other words, so you see now at what color to use? Blue, right? So you're saying at x equal -5, d2y dx squared is equal to 6 by -5 plus 6, which is equal to -30 plus 6, which is equal to -24. All right, and since this is negative, so you say now, which is, so you say d2y dx squared is less than 0. So that means that you have a maximum point. All right, so this is a maximum point. And then when x is equal to 3, right? Rubbing off here now. When x is equal to 3, at x is equal to 3, your d2y dx squared will be equal to 6 by 3 plus 6 is equal to 18 plus 6, which is equal to 24. So since your d2y dx squared is greater than 0, then you know then that you have a minimum point. So in other words, the 3 minus 21 is the minimum point. All right. So that is a straightforward, straightforward. You couldn't want it more straight than that. All right. Straightforward revision. You might get something as straightforward as that in a question. Very, very possible. Sometimes the straightforward thing is what trip people up. All right. So let me do one more. And then we call that a night. Nice. Hey, beautiful question, man. Jeez and ages. Number 10. Right. So, last question for the night, right? We don't really have a choice but to go for like 2 hours when we're doing these sessions, right? So, once all you know we have these sessions, just prep yourself. I had to prep myself too. Try to move around as little as possible during the day. Stay home, relax. Mark, you miss out a nice session at the beginning of the class, man. In fact, most of them miss it out because it was Tashera and Khadija who were here at the beginning. And I think Jabari came in not too long after. Nice music and thing. Rock them all Afrobeats. Just the vibes of the session, all right? So be mindful of your physical energy, right? Even though you're young, and you could stay up all night and go to school the next day as if nothing happened. That is fine and that is great. But you still need to be aware of your energy. Get your rest when you need to. Right? Mark, you had football today. Jabari, you was playing football too. Brandon, I ain't sure what you do for recreation yet. But you know, everybody have the thing that they do for recreation. Right? Do that, get your rest, and then push hard again. Right, so last question. Now we finish. Now we rock them for the night, number. Right, so we need home stretch for this question. Right, so after tonight, well, they have a whole week to kind of go back in this topic again. Right, well, you could start by watching the session again. You all will have these same questions to do in the past paper. So in other words, in the next past paper that you get, you go in section 3 and you're looking for this topic because they had a whole session on it. That is how we had to do it. And as we do more sessions, you look for the past papers and you build up section 3. It's not as intimidating as it seems, but it takes a lot of work. It is not by any means a walk in the park. Right, question 10. A curve has the equation. The equation is y is equal to 3x cubed minus 2x squared plus 2x. All right. Part 1, show that the equation of the tangent to the curve at the point where x equals 1 is. y is equal to 7x minus 4 at x equal 1. So they ask you to show that, all right? And then part 2, find the coordinates of the point where this tangent meets the curve again. Oh my word. Beautiful question, boy. All right? Now, one thing I want you all to notice. If you notice in all the questions we did so far, the equation of the curve was always a cubic equation, right? Which when you differentiate, you'll get a quadratic as the first derivative. And then when you differentiate that to get a second derivative, you get a straight line. You get a linear function, right? That is not by accident, right? So it is highly likely, and I want to believe that they made explicit mention of that in the syllabus as well, in terms of the kinds of curves that they had to deal with. At least for sure in section 1 with the remainder theorem, they carry it up to the 4th power, the 4th degree. But starting with that curve of x to the power 4 here doesn't really serve any purpose, because when you differentiate that, you have a cubic curve. Unless, of course, you have a situation where having started with a curve in x4, they might give you one of these solutions, because remember, when you solve a cubic equation, you have three roots, right? So they might give you one of the roots, and then you might have to find the other 2 roots, which sounds like a remainder theorem question. So you might, or they might give you 2 of the roots and ask you to find one, the remaining one, which is still remainder theorem, but in a differentiation context is less headache, right? So again, I just throw in all these things at all, so you could be aware of it. Most times the cubic curve is what they will start with. You differentiate and they get a quadratic, and then you differentiate and they get a linear. But don't take that as gospel. They might deviate from it, right? They might start with a quadratic curve too, which I think we did a question like that earlier. So sometimes they do actually start with the quadratics, and when you differentiate, they get a linear, pretty straightforward. They generally wouldn't start with anything greater than cubic. So you see where your consideration of polynomials in section A come back to knock on your door in section C. All these little things you had to notice. You had to notice what happens when you differentiate. And of course, when you're doing the reverse now, they trick you with a linear, and then they integrate and they get a quadratic. And then they integrate and they get a cubic. Yeah, right? Right, so let me finish now. So they wanted to show that the equation of the tangent to the curve at the point where x equal 1 is this, right? So if we're talking the equation of the tangent, the first thing we have to do is differentiate. So we're saying that dy dx, right? dy dx is equal to 9x squared minus 4x plus 2, right? So that is the gradient function, which will give you the gradient of the tangent at any point. So at x equal 1, right? So at x equal 1, your gradient, which is the same thing as dy dx, is equal to 9 by 1 squared minus 4 by 1 plus 2, which is 9 by 1 minus 4 plus 2, which is 9 minus 2, which is equal to 7, right? Look at 7 right there, gradients. Y is equal to mx plus c. So you're sure you're inside here already, right? All of this is what you had to go through. Right, so we have the gradient and we have the x coordinate, but to find the equation, we need the y coordinate as well. So we had to go back here to find the y coordinate, right? So let me chuck it in the corner here now. A different color ink. At x equal 1, y is equal to 3 by 1 cubed minus 2 by 1 squared plus 2 by 1, which is equal to 3 by 1 minus 2 by 1. Right, I'm not taking any chances. Plus 2. 3 by 1 is still 3. 2 by 1 is still 2 plus 2. minus 2 plus 2 is 0, so that'll just be equal to 3. So the actual point is the point 1, 3, which is to say then that now that to find the equation of the line passing through 1, 3 with a gradient of 7, we could then say that y minus 3 over x minus 1 is equal to 7 over 1. So y minus 3 is equal to 7x minus 7. You carry the 3 across, you get y is equal to 7x minus 4. And minus 7 plus 3 is minus 4, right? So again, it's pretty straightforward, but again, you see how much writing you had to do, right? And as I tell people all the time, in a lot of cases, it is not always that the question is hard. It might simply be that the question is long. And Brandon, I think it was you I was having that discussion with. Yeah, right? The question is long, so you just have to get accustomed to plenty writing. And going through the past papers at this stage to finish a month and a half before the exam, that is part of your preparation, right? We don't want to be scrambling with this 2 weeks before the exam. Right, so we proved that already. And the last part of the question before we finish, find the coordinates of the point where this tangent meets the curve again. Oh, yeah, I love trouble. How are we doing that? Now, basically, let me see if there's any shorter way to do that first of all. Anybody seen any shorter way to do that? No? Right, so this now takes us back to section 2, coordinate geometry. The intersection, section 2? Yeah, coordinate geometry is at the start of section 2. The intersection of a straight line and a curve. So again, you see how they could, now this is a Cambridge question, right? So the syllabus might be a little different. But even as we do the Cambridge questions, you're seeing that even as we do a question on differentiation, we're getting a chance to revise your coordinate geometry from section 2, right? So intersection of a straight line and a curve. Yeah, first thing in section 2. Remember, folks, that we have to deal with the intersection of a straight line and a circle, right? They didn't really explicitly mention that in the old syllabus, but it is explicitly mentioned in the new syllabus. So we had to do some questions on that later. So what we will do is just find the coordinates of the points of intersection of this straight line and this curve here. So how are we doing that? Well, normal thing, simultaneous equations, not so? Going back to section 2 in your maths, question 8, relations and functions, right? So this, we're killing 2 birds with 1 stone here. Question 8 in your maths and section 2 in your Add.Maths, right? So we have the equation of a curve and the equation of a straight line. So we're saying y is equal to 3x cubed minus 2x squared plus 2x, that's equation 1. And we're saying that y is equal to 7x minus 4. Ooh, pressure, boy. Anyway, no. Ah, all right. This is a tangent, so you'll get a double value here. X minus 1 into x minus 1. I will explain it in a little bit, right? You see how much things we had to consider here? As equation 2. And that is why the Add.Maths is so nice. So I want us to take a deep breath here. I know we're nearly done. Don't lose all the concentration yet, right? We have a very important thing coming up here that I want us to pay attention to. This is the kind of thing that you could carry into the exam with you, right? Now, you have a cubic equation here, right? which means that it is quite possible that this line could be the curve in 3 points, in fact, that is exactly what it means. Well, it wouldn't always be the case, but hold on. If you have a cubic, that's what a cubic curve look like. Straight line, boom. You have 3 distinct points, right? Or, watch it, you can have a tangent and 1 extra point here. You could have that. Remember when we do in the case of the quadratic, remember we have quadratic straight line, 2 distinct points, or you can have a tangent. In the case of real roots, the same argument will hold as well if we're talking about a cubic curve and a straight line. You could either have 3 distinct points of intersection, or you could have 2 points of intersection converging at 1 point, which is our tangency, right? And another point here. Now, we already know that this point here is the point where the equation of the tangent is 7x minus 4. So we know for starters, and I'll just be in general here now, that this point 1, 3 is a tangent. So in other words, you have a tangency here at 1, 3, which means that there is only one other root here because it's a cubic curve and a straight line intersecting, right? Generally speaking, no, I shouldn't. Yeah, you might get a cubic. You may get in section 2 to find the points of intersection of a cubic and a straight line where you have 3 distinct points of intersection. Chuck that in the back of your mind somewhere. So if it comes, you wouldn't be shocked. But seeing that we're dealing with this whole topic of tangency and gradient of a tangent and equation of a tangent, then this 1, 3 is a tangent here, right? And no more solid didn't see that. So I throw in that at all, right? And then you have 1 more point of intersection here. So, and that is why the question says, find the coordinates of the other point of intersection, because there is only one other point of intersection. Because it's a cubic curve we're talking about, which means that you have a tangency at 1, 3, which we already established based on the fact that they ask us to find, to show that the equation of the tangent at x equal 1 is y is equal to 7x minus 4. So in other words, the equation of this tangent here is y is equal to 7x minus 4 at the point 1, 3. This is the general curve here. So this here is the curve y is equal to 3x cubed minus 2x squared plus 2x. So this is the extra point that they're asking us to find, right? So I just given you all a visual depiction. Now you could get this on the internet too, right? There are websites where you could actually put in the equation of the curve and see the intersection of the curve and the straight line, right? I know they don't have much time to play with these days, but maybe one of these days when you're doing a question, you could just do it just for fun, right? Wherever possible, I would actually give you a graphic, but it's something you could do on your own as well. Right, so let me finish it now. So you now have 2 simultaneous equations. One is cubic and one is a straight line. Something that you wouldn't usually get, but in this case, because we have a tangent, that would simplify the working as we proceed. So you do your normal thing, you substitute one into the next. Well, it's not even so, well, yeah. If y is equal to 7x minus 4, you substitute it here, right? So between these two, you could simply say, therefore, 7x minus 4 is equal to 3x cubed minus 2x squared plus 2x, all right? And then we bring everything on one side. So 0 is equal to 3x cubed minus 2x squared plus 2x, watch it now, minus 7x, and then you bring the minus 4 and you put plus 4 here, all right? So 0 is equal to 3x cubed minus 2x squared minus 5x plus 4. All right. So now we have to solve this cubic equation. Well, we don't know two solutions already because we have a tangent, right? Or you could use the remainder theorem. You could divide this by this because you already know that x equal 1 is a solution. So you know that x equal 1, you know that f1 would be equal to 0, which means that x minus 1 is a factor. Let me just run through it quickly and demonstrate it, right? 3 by 1 cubed is 3, minus 2 by 1 squared is 2, minus 5 plus 4. 3 minus 2 is 1, minus 5 plus 4 is minus 1 equals 0. All right, so again, we throw it back into the remainder theorem, right? So you see now application of the remainder theorem here. We know that we have a tendency, so we could also, well, we could do long division and find the remaining quadratic, or, and I'm gonna do this, well, yeah, let me do it 2 ways and done, right? I just rub off the thing. Jeez. Anybody wrote down this equation? Yeah? Well, it was writing. Okay. All right, let me do it over quick. 0 is equal to 3x cubed. Yes, I know all tired, right? Just bear with me a little bit. We're nearly done. So all you feel me tired too? You feel is only all alone tired? Okay. Very nice. Well, you don't like me, man. 3x cubed minus 2x squared minus 5x plus 4. Right, so that is the equation, right? So I'm gonna rub up it up because we don't really need that again. And we're just gonna solve. So we know that 3x cubed minus 2x squared minus 5x plus 4 is equal to 0. In which case we could say then, we already know that x minus 1 is a double solution. So we know that 3x cubed minus 2x squared minus 5x plus 4 is equal to x minus 1 into x minus 1 into, the only thing this could possibly be here is 3. So we could put 3x plus, let me say, k, some constant k. Why I know this is 3x? Because they have 3x cubed here. If we have a double solution at minus 1, which is the tangent, then the only thing that this could possibly be here is 3. Again, I just stretching all that a little bit. All right. So we could find the value of k by simply equating the constants, right? Well, let's see why I like to do Cambridge questions. All right. So you say equate constants. Equate constants. Right? So 4 on the left side is equal to what? Minus 1 by minus 1 by plus k. 4 is equal to minus 1 by minus 1 by k. So 4 is equal to k. All right, 4 is equal to k. Right? It makes sense because minus 1 by minus 1 is plus 1. Plus 1 by 4 is the same 4 there. All right? So it means then that the third solution is, therefore, third solution is equal to, third solution is that x is equal to minus 4 over 3. Right? Now I know. I don't have to explain that. Right? 3x plus 4. Right? X equal minus 4 over 3. And when x is equal to minus 4 over 3, we then substitute it back into the original equation to find y, and the problem done. So we just do that fast now, right? Let me see. Right, so when x is equal to minus 4 over 3, right, I'm rubbing it off here, right? So I'm making sure we deal with this 2 times tonight, right? Equation of coefficients and all of that. So at x equal minus 4 over 3, at x equal minus 4 over 3, y is equal to 3 by minus 4 over 3 cubed minus 2 by minus 4 over 3 squared plus 2 by 4 over 3, which is equal to 3 by minus 64 over 27. Look at it again. Same thing we did with earlier. Minus 2 by 16 over 9 plus 8 over 3. All right, which is minus 128 over 27. No, we could just divide each into 27 and make it 9. All right, so you get minus 64 over 9 minus 32 over 9. Make life easy for yourself. Plus 8 by 3 is 24 over 9. And no, all you know what I do there, right? So minus 64 plus 24 is minus 40. Minus 40 minus 32, which is equal to minus 72 over 9, better known as minus 8. All right, so the third point is the point minus 4 over 3, comma 8, end of discussion. All right? Right, so I'll get a serious workout tonight, right? And this is an introduction of what is to come, right? That's the whole point of what we're doing here. Right? If it is not workout for me too, I look into go and sleep now. Right? So now that all you know what we're about, right? I want all that to psych up on yourself. Right? Basically, we'll be doing these on Wednesdays, in addition to the past papers that I will send for you to do. Right? Again, I'm making it clear. The intention is not to be scrambling in June for this Add.Maths. There is one subject you don't want to play around with in terms of scrambling is Add.Maths. You might get away with that for maths, not Add.Maths. Right? Add.Maths, you need as much time as possible coming down to the end. So just be tying up loose ends. You don't want to be scrambling looking for past papers 2 weeks before the exam. Not my students anyway, right? So I appreciate the outstanding cooperation for this session, and I trust that that will continue right through until the end, right? I want to give the fellas in the group, the boys, a special mention tonight, because you know normally people say the girls is the one who does be talking in class and right? I am proud of my gentlemen, and I want her to keep that up, right? And ladies, we want her to fall in line as well, right? We don't want people shy to express themselves and they want to give the answer and they're afraid it's wrong. Nah, forget that. If it's wrong, it's wrong. We'll fix that. That's what we're here for, right? Anybody have any comments before we go? Anything? Well, I don't see that time for no small talk now. I just want to go. Right, so that is it. So again, I appreciate the attendance and trust that it will continue. By tomorrow, I'll collect the remaining past papers. So by weekend, all you'll get that back in an email and all you'll get the next past paper. So Brandon, you have a little extra time to play with this week, right? Use it to do some of your other work, and then you'll fall in line with everybody else with the next past paper, all right? So, no, actually, no. Brandon, you finished the past paper already. So you have 2 weeks to play with. Beautiful, beautiful. Right? But we have some integration work to do. So we have this, yeah, getting away from me. Right, so let's take care, keep good. All who going to sleep, have sweet dreams. All who going to do extra work, take a little rest, and then go at it again, right? That is the phase we're in now. Mark, I know you pumping because you've had a sweat this evening. So if you had to stay up all night, you stay up all night, man. That is the name of the game, right? Do what all you had to do now. And when the exams finish, you do what you want afterwards. All right. So I'll keep good. Next week, please God, we on again. And sometime over the weekend, I will be in touch with all of you. Right. Boom. Later.